So section 2-7, transformations. So we are going to be talking about our general equation again for absolute value and being able to describe where our vertex is going to move from the origin and then what the slope is going to make it do to the graph. So that includes which way it opens and if it's going to be a little bit skinnier or a little bit wider. So again, from our previous section, at the end of that video, we talked about how the slope here is affecting our graph. So if we have a bigger number, it makes it skinnier. Whereas if we have a fraction of some sort, it's going to make it a lot wider. And then the number inside with the x makes it move either left or right. And then this number makes it move up or down from that origin point. Okay. So and we are going to call those transformations. Okay. So when we are looking at this, there's a couple different ways that we can approach. So usually the easiest is being able to figure out the vertex, so your H and K, and then you are describing the vertex in words. So this would move it left or right depending on the sign, and then this one moves it up or down. And then our A value, again, we are referring to as the slope, affects the direction, and then if it's going to be skinnier or wider. Okay. So this H makes it move left or right. Our K value makes it move up or down. And then A has two jobs. So if it's positive, it opens up, which since it's normally positive, we aren't going to call that a transformation, but if it's negative, it opens down, which we are going to call a reflection. Okay. And then if it's something other than 1, so if it's bigger than 1, and we would ignore the negative part, so if A is bigger than 1, that's going to make the graph skinnier because we're going up faster than we're going over. We are going to call that a stretch. So makes graph skinnier. Okay. And then if it's between 0 and 1, so if it's some type of fraction or it could be a decimal. Now keep in mind your fraction does have to be smaller than 1, so you might have a bigger fraction than 1, so you need to make sure that you're paying attention to that. But we're going to call this a compression. Or you might see the phrase shrink, depending on what you're reading, but I'm going to use the phrase compress, and this is going to make the graph wider. All right, so let's just say we had the example y equals 2 absolute value of x minus 3 plus 5. So if I just figure out my vertex, so vertex would be 3, 5, so still the opposite of whatever's inside, and then my slope is 2. So for my transformations, I'm going to describe how I would move my pencil to graph this. So I have to go to the right 3 and then up 5. So those are 2 of my transformations. And then if our A value is anything other than 1, we are either going to have a stretch or compress. And then if it's negative, that would be the reflection. So since this is bigger than 1, I would say that there was a stretch, which means when we graph it, it's going to be skinnier than normal. Okay? And if we need to, because this is positive, this is going to open up when we graph. Let's do one more example. So let's say I have the equation f of x equals negative 1/3 absolute value of x minus 2. Okay. All right, so again, my vertex is 0 because I have nothing inside with the x. And then my k value is negative 2. And a is negative 1/3. So for my vertex, again, we're describing how we move our pencil. So I'm going to go down 2 And then for my slope, there's a negative, so that means that it's going to open down, so that's the reflection. And then because I have that 1/3, that's going to make the graph wider, so I also need to say compress. Okay. And if we need to, this is going to open down, again, because my A was negative. So we might have all transformations, we might have one or two. So it just depends on the problem. So we don't have to list the transformations every single time. Okay. All right, so I would like you to pause the video, see if you can list out all the transformations for these 6 problems that I have. And if you think you know what you're doing, you can also go ahead and list out domain and range. All right, so for each of these, I'm going to list the vertex and the slope because that will help me with the transformations. So it's not actually part of what the problem is asking, but we need to know that to be able to answer the questions. So vertex is -2, 3, and I have a slope of 1. So my transformations, well, first of all, I'm going to start with my opening. So A is positive, so this is going to open up. And then I'm going left 2, up 3. And then since A is 1, there is no stretch or compress. And if it's not negative, there is no reflection. Okay? And then we'll come back and do domain and range. All right, so vertex is 0, -2, and I have a slope of -1. So because my slope is negative, this is going to open down. And then I went down 2 for the vertex. Okay. And then since it's negative, I also need to say that there was a reflection for my transformations. All right, next one. So vertex is 1, 0, and my slope is 3. So slope is positive, so that means it's going to open up. And then when I describe this point, I'm going to the right 1. And then for my slope, because it's bigger than 1, it's going to make my graph skinny. So this is a stretch of 3. All right, number 4. Vertex is 5, 2 with a slope of 1/3. Slope is positive, tells me my graph is going to open up. Describing the vertex, I'm going to the right 5 and then up 2. And since my slope is a fraction between 0 and 1, this is going to make my graph wider because I'm going over faster than we're going up. So this is going to be a compression. So compress 1/3. All right, next one, vertex is 0, 0, and my slope is -7. All right, so since slope is negative, this is going to open down. For my vertex is 0, 0, so I didn't go left, right, or up and down, so I'm not going to write anything for that. Since this is negative, that is the reflection. And then when I look at just the 7 piece, that's bigger than the 1, so that means that this is going to be a stretch. So it's making my graph skinny, so I have a stretch of 7. All right, last one. So vertex is at -5, 0, and my slope is -3/2. So since slope is negative, this will open down. Describing my vertex, I'm going to the left 5. I have a negative slope, so that's a reflection. And then 3/2 is bigger than 1. And I know that because my top number is bigger than the denominator, so this is bigger than 1, which means it's going to make the graph skinnier because we're going up faster than we're going over. So this is going to be a stretch of 3/2. All right, so now let's go back and talk about domain and range. Now, we know that these are absolute value equations because we have the absolute value symbol with a variable in it. And the domain every single time, because we never skip an x value when we make a v shape, is going to be from that -infinity to +infinity. Or again, the other phrase that we would use is all reals or all real numbers. Okay. So now I'm going to have to go back and figure out what the range is. So remember, for the range, we always use the y value of the vertex, and we already have that listed for each problem. And then it's going to go from the y value of the vertex to positive infinity if it opens up, or from negative infinity to the y value of the vertex. Okay. So this is where it becomes important of being able to have a general picture in our head when we're graphing. So we already know that this V shape is opening up. So again, if I just kind of do a sketch, it's going to open this way. So that means that I'm going from the y value of my vertex, which is 3, to positive infinity. Okay, here we're going down, so my V shape is going this way. So when it opens down like that for the range, it's from negative infinity to the y value of the vertex, which is -2. Okay. Here I'm opening up. So if it helps you, do your sketch on your paper so you see it. So this is from the y value, which is 0, to positive infinity. On 4, going up again. So this will be from 2 to positive infinity. Here we're opening down. So y is 0, so this will be from negative infinity to 0. And we should be doing brackets on our number because that point is on our graph. And then this one, again, opening down. So this is coming from negative infinity to 0. And we are always using the y value of the vertex. Okay. Now again, if you would rather write it as an inequality, that would be acceptable too. So if it doesn't tell you how to write it, then you get to choose. So if we need it, this would be y greater than or equal to 3, y less than or equal to -2, y greater than or equal to 0, y is greater than or equal to 2, y is less than or equal to 0, and then y is less than or equal to 0. Now, if you get really stuck for these, since we know how to graph, you can physically graph it, and that should also help you with the transformations and domain and range. And to just kind of be clear, the transformations is this part. Okay, so the way it opens does not count as a transformation. So I'm just kind of highlighting what the actual transformations are for each of these. Okay. And we could have all 4 transformations, or we might have 1, or we might not have any. So it just depends on the problem.